This is a problem that we have already done. I want to show you an easier way of doing this as long as you know your powers. And you're probably wondering, how could it be easier? Well, we know there's a common base between these guys, right? And what was that common base? 2. So I'm going to use that change of base theorem. That change of base theorem says that you could do, like you could straight up just do log of 32 over log of 8 if you wanted to. And of course, that means you could then go to your calculator and type that in. I don't want to do that. I want to make sure we understand that the common base was 2 and put that here, base of 2. Now you have two smaller problems. And for this guy right here, what power of 2 gives you 32?
2 to the 4th. No,
Nope. It's 2 to the 5th power, right?
yeah.
And what power of 2 gives you 8?
3 square cubic.
3. Right? And wow, if I go back 3 pages, 3 pages! Look at this. I want you to check this out. That's the same thing that we got before. Look at how much work we had to do, though. If you can identify a common base, it's like, boom, done, son. What do you think?
Well, so you said we could have written it as, without the 2 subscript there, just log 32 over log 8 and plug it in. Would that make it log base 10?
It would. It would make it log base 10. So that means that you have to be very careful about what you do. And I'm going to show you here on the calculator. Okay. So on the calculator, if I type in log of 32, now this is where you have to be careful about using your parentheses if you're going to use a calculator. If I do log of 32, I've got to close that off, so I'm done with that log, divided by log of 8. I get the answer 1.6 repeating. Okay? So,
And that's 5 over 3.
yeah, it's 5 over 3. So if you want to check that, you can do 5 over 3, boom, same thing.
So what was the difference in, like, if the calculator uses log base 10 and we were using log base 2 for our, like, you know?
It's just all about how the ratios work. I could have done natural log. I could have done natural log of 32, close parentheses, divided by natural log of 8.
Oh, okay, so it's just consistency across.
Yeah, so as long as you choose the same base, you don't want to say log base 2 here and then log base 10 here. That's not going to work. It has to be the same base. Does that make sense?
Yeah. And a logarithm isn't like a constant like e is. It's like an actual function. What does a logarithm mean? Is it like an equation that is too long for us to see or to do?
No, a logarithm is like doing a radical, like we were showing before.
Oh, okay.
So let's
I guess I'm confused with its words. Yeah, it looks different than
Words.
Than a symbol.
Square root. That's words.
The radical.
So that symbol is representing words. So now we're just using a word to represent a word.
Okay. Makes sense.
You're right. I know. Is that what? It is brown. You have a problem with that? Thought a nice change of pace would be good. Also, the black pen ran out of ink. Yeah.
It wasn't your choice.
I mean, and look at this. I put the old ones here, just in case someone wants to use it for like half an inch. All right, so here's what I want you to see. I've got a radical, right? And this radical is kind of a problem. But here's what we know. And this is where we're going to use some of those properties of logarithms that we talked about on the previous page. I can rewrite this to be 125 raised to what power? How do I rewrite the 7th root? As 1 over 7, right? And we had a property of logarithms that says if you have a power in your logarithm, you can actually write that out in front and say, as a product, that's 1 over 7 times log base 25 of 125. The power up here becomes a product out in front.
So you don't put the power on front of 100 multiplied by that.
If I'm doing a product, I'm going to put it in front and not behind.
That's what we wrote down.
Yeah. Now, I need to evaluate this log base 25 of 125. I'm going to again use the change of base theorem because these guys have a common base. And what is their common base? The common base is 5. Now I want you to watch what I'm doing here. You said the common base is 5. So I'm going to write both these, base 5 and base 5. Students oftentimes get confused about what number goes where. I don't see how they get confused because I'll look at it like this. See how this is my base of the original log? This base, base goes in the bottom. This guy's in the top, so to speak, and so he goes in the numerator like that. So now we work this out. This is 1/7 times, what's log base 5 of 125? Remember, the answer to the log is the power. So what's the power of 5? 3 over what?
2.
You just have to multiply two fractions, and you get what? 3 over 14. And just so that you guys are aware of this, you also could take this expression and say, all right, 25 raised to some power is equal to the 7th root of 125. You could have taken that as an exponential equation and taken it off to the side, get those common bases, and work it out. Yes?
If 25 is a common base of those as well, right?
It's not.
Because, oh, well, no, never mind.
Because see, 25 to the first is 1. 25 to the first is 25. 25 squared is 625. Not a common base.
Yeah.
And when I say common base, we want to make sure that it's a common base where you could raise it to an integer power. And so you're not dealing with weird stuff. Okay. Now, if you have calculators, then you can take care of something like this. Log base 7 of 99. So we'll just pass these out for you. I got a few of these here. Share if you can. If you have log base 7 of 99, do these have a common base? Do 7 and 99 have a common base?
You just handed out some calculators, I'm guessing that they do not.
What? Maybe this is a trick.
It's context clues. Well, not but I don't think they have a common base. There's 99.
You guys have calculators, it's great. Another one.
I mean, 33. That's definitely not a common base.
Well, think about powers of 7. 7 to the first is what?
7.
Okay, 7 squared is...
9.
Okay, we're not there yet. What's 7 to the third? That's 343. So we know that we went from 49 to 343 and 99's in between, right? So my answer has to be between 2 and 3. Okay? So 7 squared was 49. 7 to the third is 343. So my answer has to be in between 2 and 3. This is where the change of base theorem comes in handy because you don't have a common base. This is where, on your test, you have to have a calculator because you just can't do this by hand. And you can't do this on a 4-function calculator. Okay? So if I rewrite this and I say log of 99 over log of 7, and here I'm using common log. You also could use natural log. As we've seen before, it does not matter. Okay? So I'm going to say log of 99 divided by log of 7. Now I'm going to move this. I feel like I gave too much away. Are you getting a number that's between 2 and 3? Is everybody getting a number between 2 and 3?
4, 2, 4, 4, 7.
Whoops. So we get 2.36. Now typically what you're going to see, in my math lab, they may say round to 4 decimal places or round to the nearest thousandth. Please make sure that you round correctly. I'm going to say round to the nearest thousandth. That means 3 decimal places. So 2.361. So this is approximately 2.361. What do you guys think? Too easy? Suppose you did natural log instead. Suppose you're more of a natural person, right? I don't like those GMOs. All right, so if I do natural log of 99 divided by natural log of 7, should I get a different answer? No, not if what I told you was correct. Oh, look, it's the same thing.
Mr. Craig, did you know that's going to happen?
I mean, every day's a mystery. Embrace it. Let's do some even funner stuff. If I say, what is the log base 83 of 1? What do you think you would tell me?
83 to what equals 1, it's just 1. Or it's 0, I mean.
Right, so think about it off to the side. 83 to some power is equal to 1. What power do you raise a number to get 1? 0. Even if it were a really nasty number. If I said, what is log base 9.036 of 1, what would you say?
0.
You would say 0. If I ask you what is log base 37 of 37, what power of 37 gives you itself?
1.
The answer is just 1. Does that make sense? And I could go extra crazy here, and I could say, all right, hotshot, what's log base 52 of 52 to the square root of 7 power?
It's power, so that means you bring it to the front of your log.
You could bring that power to the front, but here's the thing I really want you to see. The base of your log is 52. The base of this expression is also 52. The theorem on inverses says that those guys basically cancel out, leaving you with what? The square root of 7. Right? Isn't that cool? It's like you don't even have to do any work.
Because it would be like 1 to this square root of 7, which is...
No, it would not be.
Because what do you mean they cancel out? Because we're left with 1.
Let's do it this way. Let's do what you said. You said this power can come out to the front, right? So that would become the square root of 7 times log base 52 of 52. What's log base 52 of 52?
1.
1, so this is the square root of 7 times 1, and that's still the square root of 7. Is that cool? Now let me switch gears a little bit and do this. What is log of 100? If I just write log, what does that mean?
Log of 10.
That means it's understood. So it's understood to be log base 10. And what's the power? This is the answer here.
2.
10 squared is 100, so the answer here is 2. What do you guys think? So then what if I say, what's log of 1 over 100,000?
You can do them individually and subtract them.
Minus
I could.
minus 100? Oops, I'm sorry, minus 3?
No. What power of 10 would give you 100,000? You're thinking too hard about this. How many zeros do you see?
5.
No. 1, 2, 3, 4. We see 5 zeros, right? So this would be 5, but since it's in the denominator, it makes it negative 5. Because think about what happens. If you do 10 squared, you get 100. 2 zeros. 10 to the third is 1,000. 3 zeros. Think there's a pattern? Yup, yup. All right, let's see if we can fill out this page here. Log base 19 of 1 is what? Still 0, right? If I do 8 raised to the log base 8 of 461, Right, since the base of the exponential and the base of the log are the same, you get just the number inside 461. Yes? If I say log base 7 of 1 over 49, it's negative 2, because if I look at this, right,
It's 2.
that would be 2, but since it's in the denominator, it's a fraction, it's negative 2. Do y'all agree? Log base 3 of the 13th root of 27. So if I didn't have the root, if I did not have the root here, what power of 3 gives you 27? The third power, right? And where does that index go? That's it. If I do log base 2 of the 11th root of 32. No. What power of 2 gives you 32? Start there.
5.
That's 5.
11.
And then you take the index, you divide by 11. Right, because this means the 11th root of 2 to the 5th power, right? And this guy becomes 2 to the 5/11ths. And since these powers, or the bases would match up, that's the answer I'm looking for. That's right, unagi.